Hello everyone, this is Mr. Huebner, and this is part 3 of molecular geometry notes. We left off on one of the other sections on BRF5, and that was the cliffhanger. And we said that bromine is going to be the center because it's least prevalent. We got to figure out bromine. I know that's 7 valence electrons. How do I know that? Because it's 1, 2, 3, 4, 5, 6, 7. It's a halogen. What are we talking about? Bromine. Yeah. 7 valence electrons. Alright, so counting those valence electrons, we got 7. Fluorine also has 7, and there's 5 of them. So that's basically 7 times 6. That's always a hard one to remember. What was it, 42? Okay, 42. Always 4th grade, I had to memorize my multiplication tables. That was the tricky one. Alright. We got fluorine. We got fluorine, we got fluorine, we got fluorine, and another fluorine. There's 5 of them. And we got 42 electrons we're dealing with. 2, 4, 6, 8, 10 are already out. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Alright, so I think I had 40. 40. Oh, but I have 42. So where do I have 40?
On the bromine.
On the bromine, on the center. So here we have 5 outer atoms. It looks like we got 1, 2, 3, 4, 5, and a lone pair. Whoops. 5 outer atoms and a lone pair. It's square pyramidal because the lone pair pushes back on these, making it kind of flat. So this is square pyramidal. Alright, and basically you've got 5 outer atoms. Is there any other one that has 5 outer atoms? There is one actually.
Triangle bipyramidal.
Triangle bipyramidal. So the difference is no lone pairs versus lone pair. Lone pair versus lone pair. So this is going to have 1 lone pair on center atom. Alright, and the bond angle is a memorization thing. If it's trigonal pyramidal, you got 90 and it's less than 90. So the little guy coming down is going to create a less than 90. Otherwise, oh shoot, alright, this guy down here is going to be less than 90, but then the 90-degree angles are right there. So 90 less than 90. Alright, I think that is it. We're going to talk about hybridization later. I'm going to look at the test to see if that's on there. We'll go over it. Okay, this doesn't look like square planar, so I wrote my rough draft. We gotta final copy that, make it look like an actual square planar. So we're gonna put bromine here, we got fluorine coming down to the bottom, and then we've got, if we look at this picture, how do they show it? Square pyramidal. So they're showing that 2 are coming out of the page and 2 are going into the page. So that's kind of a way to show 3 dimensions. I mean, if you don't show the dashed line versus the solid line, if you just kind of show it in a 3D type way, that would be good enough. But let's be all official. If you just made these lines, I would accept that, and I would bet that IB would accept it as well. I've never been a moderator, so I can't say for sure. Alright, there it is. That's the official 3 dimensions. Alright, then the last one. We haven't done a square planar one yet, I don't think. So we'll do square planar. Where's my example? BRF5. Oh, no, that's square pyramid, sorry. Yeah, ICL4. I was like, oh my gosh, I used to do that multi-ring. ICL4. Well, I did CL4. Alright, we got iodine. And here, I'm going to make the rough draft. It's going to be an incorrect drawing. I mean, if you're like genius level, maybe you can like, conceptualize in your head and draw the correct answer. But people are like that. Alright, so iodine, I know is how many valence electrons? 7. Chlorine's a halogen as well, so it's 7. So I got 4, 5 halogens. Each was 7, and I got a negative, which means it's an extra. Hey, what happens if I had a positive? What would I do? -1. Got it. And I'll show you an example of that. If you have a plus or minus, you're going to have to put it in brackets. And we didn't oopsies, I'm just looking at this now. PF6 negative. Is that really PF6 negative? Yeah, we forgot to put this in brackets. Negative charge. That's important for IB. So anytime you got behind it, it's also important to put the bracket charge outside. Alright, so 5 times 7 is 35, plus 1 is 36. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I got 4 more left. I'm going to plop them in the center. And those 2 lone pairs are what are going to change my shape. Normally this would be tetrahedral if I got 4 outer atoms. Lone pairs make it square planar. Square planar. Looking at the bonding of square planar, it's 90 all the way around. It's basically like square pyramid. It just doesn't have that extra terminal pad. And 4 outer atoms, gotta have 4 outer atoms. But the difference between tetrahedral and square planar is 2 lone pairs on center. And then we gotta draw this so that it's the correct drawing, like this. So, and actually you're just gonna draw it like that, but instead of an F there, there's gonna be a pair of electrons there. Pairs are pushing against each other, creating a flat plane. And then, of course, you do need the dots. As tedious as that is. And we got square planar. Alright, we got till what, 25? 25. Okay. We should be able to squeeze everything in. Hey, I'm going to do the hybridization on this, and hybridization is a little tricky because when we get into the SP3 there's agreement in the scientific community whether that is true. But IB might still want you to know it. So basically, hybridization, this is going to segue into the next unit. This is the memorization. So you're just going to blindly accept it as a fact, and then we'll talk about why it's accepted as a fact in the next section. It's not going to be on this first test, it's going to be on test part 2. So this is just the memorization part. It's like the classical philosophy of learning. Just memorize stuff and then, well, yes, spit it out and then piece things together conceptually. Alright, so if you got linear, trigonal planar, or no, linear. This is going to be SP. So we're going to put SP right there. Hybridization. What does SP mean? Well, this is dealing with the S orbital and the P orbital, and they mesh, form a hybrid, just like hybrid cars, electric, gas, they're and 2 electron groups, you got S and P. 3 electron groups, you're going to be doing SP2. So you're going to have 2 of the P suborbitals meshing with 1 S orbital. And then if you got 4 electron groups, tetrahedral, trigonal, then it's going to be SP3. So those are the basic ones. Those aren't disputed. SP3 is 3 P orbitals and 1 S. And again, there's much more to talk about this. You're just doing the memorization. Alright, and then if you got 5, so you're doing the expanded octet. How do you expand the octet? The orbital is present for that to happen. So you got SP3D. That's if you got 5 electron groups. That's a bonded pair and a non-bonded pair. Those are all electron groups. And then if you got 6, you guys could probably guess it. It's SP3D2. SP3D2. That's as far as we're going to get with hybridization. Just doing that. I think there's some memorization questions on the test where you got to draw loose down structure statements, the hybridization. If not, it gets you a head start for the second section. Okay, moving on. Well, why don't we do an example? Let's do an example real quick. Going back, we got CLF3. What type of hybridization would that have? Well, let's look at the electron groups. I got 1, 2, 3, 4, 5 electron groups. So I'm going to have SP3D. So you got 3 P's, 1 S, that's 4, and then 1 D would be 5. How about PF6 minus? We got 1, 2, 3, 4, 5, 6 electron groups. SP3D2. Alright. Sounds like you guys kind of got that. So that's just the memorization part. The why will come later. Alright. Here's some words. I talked about it already. So this is just talking about the electron groups. So let's move on to formal charge, because that's about all we'll have time for. So, like, the question is, can you make multiple loose dot structures? The answer is yes. So then the next question is, well, which is the real loose dot structure? So, for example, let's do CO2. Let's draw 2 possible loose dot structures. Oxygen is 6, plus 6, because the second oxygen is 12, plus 4 for carbon, so we got 6, plus 4, that's 16. I think that's right. Alright, we got 2, 4, 6, oh no, here, let's take a step back. 2, 4, 6, 8, 10, 12, 14, 16. I used them all up. So, but carbon needs more, so I'm going to share some. So I got 2, 4, 6, 8, 10, 12, 14, 16. But now carbon needs another one, so typically we're going to go symmetrical, go from the other side and share. We got 2 double bonds. But hey, couldn't we do something like this, where you have a triple bond and a single bond? What's stopping that? Nothing, right? We got 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Follows all the rules.
You listen on the into the class.
Oh, Tommy. Tommy, you're here. Hey, how about Dobson? Where's Dobson? I have not seen Dobson.
Where is he?
Oh my gosh, he actually is playing hooky. Dobson, where are you? Jeez, he's missing these good notes. He's always missing. Alright. Alright, so then the question is like, will the real Lewis dot structure please stand up? That's the question. Or request, at least. There we go. So we got to do formal charge. Here's a bunch of things you can read. Or in short, formal charge equals the number of valence electrons minus the number of lone pair electrons minus the number of bonds. And the idea is you do it for every single atom. And the one that has the fewest different charges, or the lowest charge, closest to 0, is the most stable arrangement in theory. So in the experimental, how do they know this? They've done experiments. How do they know experiments that they did? But this theory or equation basically explains the experiment. Alright, so formal charge. We've got oxygen right here. The valence electron is 6. Oxygen is 6. And we minus the number of lone pair electrons. Looks like there's just 2 lone pair electrons. 1, 2. And then we got to minus the number of bonds. Looks like there's 1, 2, 3 bonds. Some textbooks will say minus the number of bonding electrons divided by 2. It's essentially the same thing as the number of bonds. 1, 2, 3. So 6 minus 2 minus 3 equals 1? Yeah, 1. Alright, so we're going to do plus 1. And then let's do carbon. So carbon is got 4 normally. It's got 0 valence electrons in that case. And it has 1, 2, 3, 4. So that's going to be 0. So carbon has a 0 charge. This oxygen is going to be a little bit different. It's got 6 valence electrons, 2, 4, 6 lone pair electrons, and it's got 1 bond. That equals -1. Alright, so we got plus 1 here. We'll see if this one works out. We've got oxygen has, again, 6 valence electrons, minus 2, 4, minus 1, 2 bonds. That's going to be 0. Oh, okay, that's a little bit lower. Carbon has 4, minus 0 lone pair electrons, minus 1, 2, 3, 4 bonds. Okay, that's 0. Alright, oxygen here has 6 valence electrons, 1, 2, 3, 4 lone pair electrons, and 1, 2 bonded, or 1, 2 bonds. And that's going to equal 0. So according to our formal charge theory, which one has the lowest charges? CO2. So this would be the most stable arrangement, therefore the Lewis dot structure. That's the Lewis dot structure. So this is a fallacy, fiction. Only in fantasy does this exist. As far as we know, at least. Okay, and that brings us to this last little statement. Here it says the sum of the formal charges of all atoms in a given molecule must equal the overall charge of the molecule. CO2 has a 0 charge. So, well, this has a 0 charge. Plus 1 when more than one appropriate Lewis structure is available, choose the one so that the total amount of formal charge is close to 0. Alright, that was so much fun, and we have 6 minutes left. I figured, why don't we... What's your favorite ice cream? Vanilla. Well, we'll save that for the check-in for these guys. Alright. Alright, we'll do one more, because that was fun, that one. So. And this one, we just want to figure out what the overall charges are. And what I'll do is I'll let you guys try it on your own. I'll pause the video. So, what are the formal charges for everything in here? Actually, what we can do, let me try to make a different Lewis dot structure. If I can, maybe I can't on this one. Yeah, I think this one only has one. So in this case, we're just looking at what are all the charges, individual formal charges. I'll pause this, give you some time to work on it. Alright, here it is. I see the ones that I've seen, people are getting it right. We got +1, -1, 0, 0, 0. Here's my math that I did. questions on that? Alright, I think that's it. Yeah, the next unit. Alright, that is finally done with the 3-section video.